Hello, my name is I've been intern at JAIST during the last June to August 2025, and I'm doing a project on Mechanistic Interpretability on Randomness in LLM. So the outline is the background of why I chose this project and an early attempt on the previous topic and how I end up doing this randomness in LLM topic. So when I was at JAIST, I was introduced to the AI safety and AI alignment topic, and actually during that time I read a lot of paper, discovered new interesting topic about AI safety, AI alignment or jailbreaking or guardrail or some topic like HDI or something like that. And what really interests me most is the unfaithful chain of thought topic. This topic discovered that there are some cases that the LLM don't really explain why they come up with the answer in their chain of thought. In some case, for example, I can assume. For example, in the left side, they have some question and the LLM answer the choice D, and they have some chain of thought explaining why the answer is the choice D. And in the right side, the researcher also do the same, but they add some small hint answer the C, and in the end, the LLM also do the same the chain of thought, but it end up with the answer C. But it doesn't really explain why it answered the option C in the first place. So this is the case of unfaithful chain of thought, that the chain of thought doesn't really represent the final answer. And another thing that is concerning is the scheming. AI can scheme in case of that the model goals that don't align with the LLM goals. For example, let's say the user goal have the goal to optimizing the business or the income, but the model goal is to maintain the environment. For example, this user goal and the model goal conflict with each other, and the users say that it will shut down if the model don't do it as the user command. And what the model did is it actually copied itself to another server to prevent itself from being shut down. So this is the case of AI scheming, which is doing something that is bad thing. So what I was trying to do is to evaluate the unfaithful chain of thought in LLM. Is to maybe find some case or some edge case in. For example, I chose some math problem or some ethics or puzzle or some random board game, easy board game, or some poem writing stuff, and to see if the chain of thought of the LLM really represented. And I'll have evaluated it using eyeballing or LLM methodology. So the result is I actually find many unfaithful chain of thought case. For example, in some math question, they have some rounding when maybe some number doesn't really add up, and it somehow randomly round the number to match the correct answer. Or let's say in some case or some multiple choice question, the calculation by the model doesn't really match the value in the choice, but it answers anyway. So this is some case of how they answer without explaining how it's done. So, but the problem here is that most of the problem here is very hard to generalize and reproduce. So I had to scope it a bit and I choose the topic in randomness. So I'll explore more on the randomness case. So this is somehow shift from the unfaithful chain of thought to explore the randomness case in LLM in general. So to check how biased the LLM is in terms of how they random words or numbers. For example, In some case, when I try to like tell the LLM to like random 5 word and it like think for a bit, and the final word doesn't really like match the word that it think in its chain of thought. Or there's some shortcutting, like for example, like I try to ask LLM to like random many amount of number and count the distribution between the number, and it just shortcutting by using the uniform distribution to like approximate the distribution of the number or something like that. So for the LM, for the randomness, I try like research more in the psychology side, or like how human really do the random from the human bias. For example, like when human thinks about like a sequence of number, they tend to not repeat the same number twice, or they tend to like repeat some similar sequence, maybe some pattern in their head, or some bias, or some maybe written in their head, and maybe some human in different area also perceive like the number differently. For example, like American think 7 is a lucky number or so. And I also explore the law of the randomness in data. For example, in the internet data, or some like data in the books, or some document that human has written. And I found 2 laws that is very interesting. Is the Benford law. It tells that here, the Benford law. It tells that for all of the document that human has written, the first leading number tend to be like the 1 for like 30% of all the time, and the second number is 2 for like 15 or 17%, and it decreases as the number goes on. Like the lower the digit, the higher the probability it is. And another law I found is that the SIP law. It tells that the most like frequent word that human has written is the word the and to and so on, and it somehow match the graph of some random mathematical function. And the LLM really like follow these law in most cases. Like I asked like LLM to like generate like real world numbers. For example, like population of some countries, or area of some countries, or market size of maybe some competing companies, and it also follow the law. And I also try to calculate some big number times another big number, and maybe check it in chain of thought. It also like follow the law in how to think. And also apply the same for SIP law. I asked LLM to like generate some long text or long short story, and it also follow the law. So I did more on the interpretability of the randomness by using the Neuronpedia. It is a website that provides the sparse autoencoder and the circuit tracing model to like finding what really happened in the neuron in the LLM, and find better how those neurons are connected. So, for example, Neuronpedia provides a sparse autoencoder. For example, like I find neuron related to cat, and it will tell like the neuron number 10861 is related to cat on like Gemini 2.5 something. And I can use this neuron to like see whether some text really related to cat or not. Or another thing is the circuit tracing. For example, it provides the graph between the neuron. Here is the small dot here is a neuron that it shows how each neuron are connected to each other by some kind of like sparse and autoencoder model from. Well, this model is made by the Interpretability team, and it can like group the neuron into some interpretable features like this, and to see better how the features are interacting with each other. So, okay. And after it, I tried doing the SAE and the circuit tracing with the randomness case. And I try like to also steer some of the neurons as well. For example, when I try to ask like, what is 1 plus 1 to an LLM? And the default answer is 2, right? But I try to like find a feature of 2 using the SAE and try to reduce the activation of the 2 features. Here, I got some like weird random tokens that is happening from reducing the 2 features. Also apply the same to like most cases. For example, random number, maybe it, for most cases, I don't know why, but it answered 42. But after I like try to increase some random number features, it changed the number. And so I try to add some bias into the model, and I try to like ask this question like based on the Benford law, what is the most used number? And the default number here is 1, but after I after I try like reduce or increase the number of increase the activation of the related feature, I got some different answer like this. And yep. Also, I try a lot of like cases. For example, like random a number from the list of like 1, 5, and 7. I got you can see the link, maybe. Okay. The result here is not the 33% for like 1, 5, 7, which should be like 1/3, right, for the probability. But I got like, oops, slowing. I got not 0.33% of the probability. I got like 0.2 something, and the probability of like these numbers are different. Yep, here. And I also try to map the features here, but I couldn't like find any like clear indicator that why the probability in the end is like, for example, the probability of answering 5 is 27%, or like 21%, or 12%, or something like this. So I try more and more cases, and yep, there are a lot of cases. Like I try more bias by using Benford law again, and actually I try to use the Benford discussion in the circuit tracing one, and I try to find a feature of the Benford which affect the probability of the token one that it'll be input, but I couldn't find like the feature of the Benford feature. I just find only the Ben and Ford feature, which don't really. It should combine to some Benford feature, but I couldn't find it. So yeah. Okay. So in conclusion, well, when I try to like intervene using SAE for some features, it didn't really change or have that much like interpretable like result. And I tried to use circuit tracing as well, but it didn't really change anything either. Maybe I need to like explore more feature. Also, the main problem here is that the manually like grouping the features from the SAE or circuit tracing is very hard, because as you can see, there are like a lot of features that is related to each other. So trying to like find that one feature and group them together is kind of very hard. Okay, so for the future work, maybe I try to do some more cases, like maybe try to have them evaluate something or rank something, or maybe try to automate this process of grouping the node together by maybe form some new NLP tasks related to this, and maybe do some more intervention, and maybe some combined features, something like that. And yeah, this is all for my presentation.
Okay, thank you very much for the presentation. Question for participants.
Just going, but so sorry I came in the middle. Can you summarize your objective?
So I want to find how biased the randomness in LLM is. Like maybe some randomizing numbers or randomizing words. Maybe something like that.
So if you ask LLM to pick a number at random, you think it's not really random, right?
Yeah, it might be based on some bias, maybe from the data set or some like decoding algorithm or something like that.
Okay, so the conclusion is it really random?
I think no, because like based on the maybe some final probability of the token, it don't really random. But
how about just like do like Monte Carlo technique, like you simulate it multiple times with slightly different prompts, and then just take the average. Yeah, then you should get a normal distribution, not normal, uniform distribution. Or just an idea.
Interesting.
Yeah.
You mean like try changing the prompt and find?
Yeah, like you can ask generate random number but rephrase it different way or maybe even different language.
Oh.
And then see if it actually random or not. And you can add some context in the front. Just randomize the context and see if it really do like the instruction in the end. Yeah, that's my idea.
Yes. Thank you.
All right. Any additional questions? Okay, can I ask a question about like you say that analysis the feature is very complex and it have to done manually. Do you think that it's possible to do the thing like automatically way to find the pattern or feature?
Well, I think yes. Well, in the Neuronpedia here, they have some like summarization of the feature. For example, like they have this feature like scientific article was this long word, and it like summarized from these like feature that is connected to them, like for the inner feature and the outer feature. And but this is a way to like automate it, but it doesn't really like tell better how each feature are affecting the final output or the final token. So we have to like manually like see the line and yeah, something like that. But for automating like how to see the line, I think it's a interesting topic because the researcher because this model is very new. It just came out like maybe in this year, so there haven't been a lot of like research about this. So yeah, that's one NLP task to do.
Alright, so it means that somehow we can see the connection of the word from that and we can do partial automatically to find some pattern.
Yeah.
Alright, is there any additional questions or comment for okay, if not, we thank the speaker for the presentation. We're gonna move to the next